Hello friends, I am Nisha Bharat and here I am going to explain on topic Raman Spectroscopy. These are the contents covered in this topic. Of course, we will see what is spectroscopy, introduction to Raman spectroscopy, Raman scattering, concept of polarizability, selection rule for Raman transitions, uses of Raman spectroscopy, comparison between Raman and IR spectroscopy, application of Raman spectroscopy. So, what exactly spectroscopy is? The study of interaction between matter and electromagnetic radiations as functions of wavelength or frequency of radiation is called as spectroscopy. So, basically, it's a branch of science concerned with measurement of spectra produced when matter interacts with electromagnetic radiations. Now, what is Raman spectroscopy? In 1928, physicist Sir Chandrasekhara Venkata Raman observed that a small amount of radiation is scattered at right angle to incident light. Later on, he noted that the change in frequency depends upon the chemical structure of molecule responsible for scattering. Raman observed the difference between the frequency of incident light and of particular scattered light was constant and was found to be dependent upon the nature of substance which is irradiated and independent of frequency of incident light. For this discovery, he was awarded by Nobel Prize in 1931 and hence the name given is given to the effect. So, as we discussed, the Nobel Prize winner, Indian physicist Sir C.V. Raman for his work on the scattering of light and for the discovery of effect named after him. Now, what is Raman scattering? The scattered light from the substance contains lines of same frequency than that of incident light. Lines with the same frequency called Rayleigh lines, those with a lower frequency called Stokes lines, those with a higher frequency called anti-Stokes lines, and the scattering referred to these is Raman scattering. We can understand Raman scattering by simply the representation. Here, when monochromatic light passes or incidents on any absorbing solution, the scattering occurs and light gets absorbed by the solution and get transmitted. So, considering to that if nu I be the frequency of incident light, nu s be the frequency of scattered light, then the difference between them would be the Raman frequency or Raman shift. If del nu is positive, then there is Stokes lines. If del nu is negative, then there is anti-Stokes lines. This observation were made by Raman and was called as Raman effect, and the spectrum absorbed is called as Raman spectrum. This can be explained by the diagrammatic theory given here. When molecule returns to the energy level higher than the original ground state, it emits the radiation with frequency lower than that of the incident beam. This gives occurrence of Stokes lines in the spectrum. And similarly, when molecule returns to the energy level lower than the original ground state, it emits the radiation with frequency higher than that of the incident light, and this gives occurrence of anti-Stokes lines in the spectrum. And the important point is that the Stokes lines are more intense than the anti-Stokes lines. Then the concept of polarizability. When molecule into the static electric field suffers from distortion, the positive charge nuclei attracts towards the negative pole. Similarly, electrons to the positive pole. This separation of charge causes induced electric dipole moment in molecule, hence it's called to be polarized. Thus, Raman involves polarization in molecules followed by re-emission of radiation when it returns to its normal state. Then polarization disappears on re-emission. Hence, this differs between Raman activity and IR activity. Raman active molecules are those who have polarizability which gets changed by stretching vibrations. This can be explained by simple example, that is CO2. For this effect, the symmetric stretching vibration in CO2 made molecule does not involve change in dipole moment, that is IR inactive. But since the polarizability of bond increases during vibrational, it is Raman active. The antisymmetric or asymmetric stretching vibration in CO2 in change in dipole moment, so it is IR active. But polarizability of one C double bond O bond increases while other carbon oxygen bond goes on decreasing, vice versa. So there is no net charge change in polarizability. Hence, this is Raman inactive, and hence, considering this diagram, these concepts get easy. Here I have given the difference between Raman and IR spectroscopy. Raman spectroscopy is due to the scattering of light by vibrating molecule. IR is due to the absorption. In Raman, the vibration is Raman active if it causes change in polarizability. The vibration is IR active if it changes in dipole moment. The molecule does not possess permanent dipole moment in Raman. The vibration concerned should have a change in dipole moment in IR spectroscopy. Water can be used as a solvent in Raman spectroscopy, whereas it is not used as a solvent in a IR spectroscopy. Sample preparation is not very elaborated in Raman spectroscopy. Sample preparation is elaborated in IR spectroscopy. Raman spectroscopy gives an indication of covalent character, while IR spectroscopy gives an indication of ionic character. Raman spectroscopy's instrumentation cost is very high, while comparatively inexpensive in IR then the selection rule for Raman transitions. For rotational Raman transitions, del J is plus or minus 2. For vibrational Raman transition for harmonic oscillator is del V, that is plus 1. Thus rotational quantum number changes by 2 units. Then uses of Raman spectroscopy. Raman spectroscopy has become widely used since FT Raman systems and remote optical fiber sampling. Previous difficulties with laser safety, stability and precision have largely been overcome. Basically, Raman spectroscopy is complementary to IR spectroscopy, but the sampling is more convenient since glass containers may be used and solids do not have to be placed into discs. Then application of Raman spectroscopy. Here I have given the MDRS instrument, that is morphologically directed Raman spectroscopy. This enables rapid automated chemical and morphological characterizations of individual component in a multi-component sample and many more applications of Raman spectroscopy. Then the references, and thank you.